Hey everybody, my name is Jakar Lewis, and I am the author of the Kiss It series Teas Math Edition, which is a workbook that I created in order to better assist you guys in prepping for the math portion of the Teas test. So when we talk about the book in particular, it's going to contain a number of things. It's going to contain a diagnostic test, which I gave you guys access to in the files. If you haven't had a chance to go ahead and complete the diagnostic, you can locate it at the top of the page under the Files tab. And it's really great because it helps you to gauge where you are, even if you just started studying or if you already started studying, and it helps to guide you as to where you need to go in reference to your strengths and your weaknesses. It also features 2 full-length practice tests, which you can use towards the end of your studying or closer to your test date to assess where you are and, again, assessing your strengths and your weaknesses. It contains over 1,400 practice questions, which, of course, I deem very essential, being that I have experience in the classroom as a math teacher. I've been a math tutor for 11 years, and I've been tutoring helping out with this test for about 7 years. So I know that practice is definitely essential in reference to retaining information, especially in terms of math. Topics are going to be mastered in one to three steps. What I wanted to do is I wanted to give you guys different ways to be able to complete the task without making it so cumbersome. So I help you guys to utilize the tools that they give you in reference to your calculator, and to be able to get through the problems as best as possible. And online resources are available as well, including these great free videos that I give you guys, in which I go through the examples that are here in the book. I'm helping you to be able to zoom in on the specifics of each topic that they give you, because the test covers 15 topics, but the problem is that when people are studying, they don't know what to focus on specifically. So today we're going to look at calculating geometric quantities. Now, when we talk about geometry, it's a wide range of things that falls under the idea of geometry, but from my experience, I'm just going to focus on the 3 things that I feel like you are most likely to see, and that's the things that a lot of the times certain products that are available will make the test 10 times harder than what it is in reality when it's a basic entrance exam. And that's one thing that everybody needs to remember, is that in terms of difficulty, it's not meant to be a really, really, really hard test, because the level at which they're gauging you is not so far out of your reach as you would think, especially the math. This is all high school level math, and of course, being that you guys are going into nursing, everybody has completed high school, so we're just reviewing things that you've already learned. So if you are interested in purchasing the book, you can drop me a comment in the announcement section, where I drop the title of the cover of the book, and it has the instructions as to what you need to do. So far, we've had some really great feedback. Yesterday, we had somebody post that after only 1 week of studying, she was able to get a 75% on her math. So obviously, if she only studied for a week to get a 75%, imagine what happens if you study for 3 and 4 weeks. You guys actually turned out to be really well. So when we talk about calculating geometric quantities, I did a small mini review a while ago, just to kind of give you guys some tidbits as to certain things that I felt like were important. So of course, I'll reiterate those again today, and then talk about some things that I did not mention in the first video. Where am I? Oh, I can't find my eraser. I don't know where it is, so we'll just have to use paper towels. Oh, here it goes. All right, so in calculating geometric quantities, there are going to be 3 main things that I'm going to cover today. I'm going to show you guys how to calculate the perimeter of a figure, how to calculate the area of a figure, as well as how to solve for missing dimensions of a figure. Those are going to be the 3 things that I feel like are the most important in terms of geometric quantities, because it's not a really big chunk of the test. At most, you'll probably see 2 questions, maybe 3, and that's stretching it. So I want to make sure I put you guys in a good position to where you studied enough, but it's not something that I feel like you should stress about to that extent. All right. So for me, there are going to be 5 particular shapes that you need to focus on in general. And in knowing these shapes, you have to know the properties of these shapes in order for you to be able to execute the problems, because sometimes they may put you in a situation to where you have a word problem, and the description of a particular figure, you should be able to decipher what the particular shape is based on its properties. All right, so we'll go through those real quick so that we can make sure everybody is on the same page. So the very first figure that we're going to talk about is a square. And of course, we all should be very familiar with squares. And when we talk about certain properties in reference to squares, we know that it has what? It has 4 equal sides. And it also has 4 90-degree angles. So those are going to be the most important properties of a square. So again, a square is going to be a figure that has 4 equal sides. And when we do these tick marks, that lets us know that all of those sides are going to be congruent, okay? And that it has 4 90-degree angles, which of course are right angles. Now this part isn't as important. I think the most important thing with squares is recognizing that all the sides are equal. So if you get like a word problem, and say if it's talking about square tiles on the floor, if we know that the tiles are in the shape of squares, I know that they have to be the same around each side. It's just certain things like that that you have to be aware of. If we do get a word problem, just know that equal sides is always going to mean a square. All right. And when we talk about a square, when we want to find the perimeter of a square, which is the distance around, and even in terms of area and perimeter, you guys have to know context-wise what that means. So the perimeter is the distance around the object. The perimeter of a square is the sum of the sides. So you just add all the sides together to get the perimeter of a square. Okay. Ouch. If you want to find the area is going to be side squared, or side times side. It's the same thing. So again, properties and formulas are going to be important. So for the geometry part, they're not going to give you guys the formulas, so you have to memorize them. And because these are all basic shapes, they're going to expect for you guys to know them. So again, when we're talking about a square is going to have 4 equal sides, 4 90-degree angles, or 4 right angles. The perimeter is the distance around. So when we think of things like perimeter, think of like a fence, like any type of fencing, any type of labeling that goes around. That's my perimeter. And you just add all the sides. Area is going to be the space that it covers, so that would be more inside. So you know when you like move to like a house or an apartment and they talk about like the square footage, how much space it covers, that's going to be your area. Okay, and the way we find the area of a square is you can do side times side, or you can do side square. It's still the same thing. All right. So if we had an example, so let's look at adding a value to the square. And I said the side length of this square is going to be 3 inches, and the question asks you to calculate the perimeter and the area. So I know, given my properties, all of the sides are equal. So if this side is 3, I can go ahead and label everything else. And this will be 3, this will be 3, and this will be 3, right? In inches, of course. Inches. All right, so if I do 3 plus 3 plus 3 plus 3, and don't mind my upside down handwriting, I know it's horrible. But I'm getting a new board that'll be standing upright, so I don't have to worry about writing upside down. So 3 plus 3 plus 3 plus 3 is 12, and the unit that we're talking about is going to be inches. All right, so when we talk about area is going to be side times side, or side squared. So I'm doing 3 times 3, which is 9. Now, anytime we're dealing with area in terms of unit, the units are always going to be squared. So I make sure that you guys know the difference, because they can trick you when you get to your answer key, okay? They can have an answer that would say 9 inches and one that would say 9 inches squared. And I don't want you guys to miss it because you don't understand the unit. So when we do perimeter, in terms of our units, it's not going to have an exponent on there. So in this case, it's just 12 inches. When we move to area is always going to be squared. So that's why we did 9 inches squared. All right, and that's going to be the key. So that's another point that you guys have to make sure that you know. So I always say, when I'm giving you guys like a lot of tidbits as I'm talking, make sure you guys are writing them in your notes as reminders so that you know and understand what's going on. All right, so do I have any questions, comments, or concerns about squares before I move on to our next shape? Nope. All right, so the next shape that we're going to talk about is going to be rectangles. So a rectangle is going to be another shape that has 4 sides, but the properties are going to be a tad bit different. And of course, I know that you guys are familiar with the shapes, but I still like to break them down so that you guys know. The difference. All right, so with rectangles, they're going to have 2 sides that are going to be congruent. You're going to have your length, your 2 lengths, and then your 2 widths. So remember, with the square, I have 4 equal sides. On rectangle, I'm going to have 2 pairs of equal sides, or 2 pairs of congruent sides. All right, and when I want to find the perimeter, which is the distance around, it's the same idea. I'm just going to add all the sides, so the sum of the sides. And then the area in this instance is going to be the length times the width. Alright, so again, we talk about rectangles. Of course, we know rectangles are always going to have a length and they're going to have a width, and they're not going to be the same. So the length and the width should always be two different lengths, because with 2 different values, because if they're the same, then obviously that means it would be a square. Okay? And sometimes people get thrown off because sometimes if it doesn't look as long, if it's not as rectangular and it's closer to a square, some people will assume that it's a square, but you just have to make sure you check the dimensions. Okay? So a rectangle has 4 sides and it has 2 pairs of congruent sides. So that's why here we have 1 tick mark to let us know that these 2 are congruent, and then from top and bottom we have 2 tick marks to let you know that these 2 are congruent, and that's how you decipher between the 2. Okay? All right, perimeter is going to be the sum of the sides, so that's my distance around my rectangle, and the area is the length times the width. So if I added values here, hypothetically, and I said that this was 4, is that a 4? And this was 8. That means that knowing the properties, I know that if this side is 4, this side has to be 4, and if this is 8, then I know that this has to be 8. So if I want to do my perimeter, which again is my distance around, think of like a fencing that kind of closes something off. That's my perimeter. I'm going to add up all my sides. So the perimeter would be 4 plus 8 plus 4 plus 8, which would be 24. And if I add centimeters as my unit, it would be centimeters. All right, now if I go ahead and I get into my area, which is my length times my width, that would be 4 times 8, which equals 32 centimeters. But remember, it's squared this time because we're dealing with area. All right, so remember again, we're dealing with rectangles. Rectangles are going to have 2 pairs of congruent sides, so our width should be the same, our length will be the same, and these are properties that you guys have to know, because if they give you an image or if they give you a word problem and they only give you 2 dimensions, you have to draw it out. And I always recommend you draw it out. If they don't give you a diagram, so that you can see visually what's going on, and it's easier for you to be able to calculate certain things. So the perimeter is our distance around our object, and we just add all sides together. And then area, we just do length times width. And one thing you have to remember to note is the difference in the units. Okay, so with area, the unit is always going to be square. And then if it took it as far to go to volume, which I doubt that you guys see on this test, volume is always cubed. Okay. All right, our next shape is going to be a triangle. Of course, we all know triangles have 3 sides. So triangles have 3 sides. They have a base, the height, and the hypotenuse, which is the longest side. Things you guys should be able to know when you look at a triangle. And I'll label them for you so that when you guys do get questions, if you have a diagram, if you have to draw one, you'll at least know where to put the values. Alright, so if you want to find the perimeter of a triangle is the same thing as my distance around, so that's going to be the sum of all of my sides. Hello.
No nigga closing out yet?
No.
Still like this bitch. Think
I'm on live.
You live?
Yes.
I still all your stuff.
Oh my God! Why would you do that?
You know I'm already mad.
Why?
I still everything in her.
Don't do that.
I already know a couple girls already.
Oh my God.
I already seen your models too. I ain't gonna talk shit about them, but
Stop doing that.
I'm just saying.
Oh my God, please excuse
I'ma
me, you
spill
guys.
your model.
He's just a passerby. I don't even know him.
I'ma smell.
Alright, are you guys looking for something in particular or just looking?
No, I seen the shorts in the window. I was like, that's cute.
Thank you. Do you have an Instagram?
Yeah, I do.
Okay, so I'll give you our card so that you can follow us on Instagram. We get new inventory every Wednesday.
Every Wednesday?
Mm-hmm.
Are you guys new here?
I've been here since September.
September?
Mhm.
Oh, this your shop?
Yes.
Yes.
Thank you.
Look excellent.
Thank you. Are you guys from here?
I'm not.
No?
No. He is.
Oh.
I'm not from here. I just got a business and stuff here.
Oh, what do you do?
I got a gym around the corner.
What gym?
Hagler Boxing Club.
Oh, I didn't know that there was a gym there. You have a card?
Not on me. Actually, I think I do. Let me see. I know my wife yelled at me the other day about not having how big.
You have oh, there's the shorts. Is that the shorts that's in
The shorts,
window?
no, so
There's
the ones that are in the window, those are my last two.
Oh.
I have one small and I have one medium left.
One.
Thank you.
Can I try the small? Are these small? Or are these?
That's a medium, but I do have a small in that style.
Can I try?
You know which-
are these over here?
Yeah, so this is that style that's on the mannequin. This is a small, and then would you like the small of the other one?
Yes, please.
Okay.
I don't know why that thick was not fitting in small.
Are these the ones you've seen? Thank you.
You're welcome. Excuse these lights.
Oh, no, it's fine. Are you doing one now?
Yeah, it's okay. Oh, no, it's okay. They know I can do things at one time. Alright, so it's supposed to be a mirror out here too. Alright, I'm back. So when we talk about triangles again, remember we're thinking about the properties. So they're going to have three sides, which are going to be our base, our hypotenuse, and our height. So you guys have to know this in reference to a diagram, because if they give you guys the particular values, you have to be able to decipher what's what if you have to draw a picture. So our perimeter again is going to be our distance around our particular shape, and in this instance it's just the sum of your sides. The area is going to be the space that it covers, and that's going to be our base times our height divided by 2. Now there is an alternative to this, which is 1/2 times the base times the height. The reason why I take the 1/2 out is because sometimes people see fractions and they freak out. So I try to make it as least cumbersome as possible. So I'm going to add some values in here so we can do another example just to give you guys an idea of how you execute the math.
Is that the medium right there?
Yeah.
All
She need a medium.
All that thickness right there.
That's not.
I baby know she thick.
Oh.
She might need a medium.
You think she need a medium for real?
Yeah, she needs a
Let me
medium.
see.
I'm dead. I'm
No,
dead
they
serious.
look.
Nah, see that extra cheek right
She
there?
look nice.
Listen, because when we try to find the area of the circumference, we're gonna have to do base times height divided by 2. And it's gonna have to slide a couple niggas down the road.
Alright, so say if we label this right, the height would be 4 inches, our base would be 5 inches, and our hypotenuse would be 10 inches. So again, if we're doing the perimeter, we're gonna add all these sides together. And if we do our area, we're gonna do our base times our height divided by 2. This is why you guys have to know the difference between the sides as you're labeling them, because if you don't, when it comes down to the area, it may cause a little confusion. Alright, so for our perimeter, we're going to do 4 plus 5 plus 10, which gives us 19 inches. And then for our area, which is base times the height divided by 2, we're going to do 4 times 5 divided by 2. 4 times 5 is 20. And 20 divided by 2 is going to give us 10. And in this case, it's 10 inches squared because we're dealing with area. So remember, that's going to be really, really, really important when you guys are going through your answer choices, because you don't want the unit to be the reason why you miss a question, okay? That shouldn't be a particular issue. Alright, so moving on to our next shape, we're going to talk about circles. So I know out of all the shapes, I personally feel like circles is what gives people the most amount of trouble, because we're dealing with a radius and a diameter, and that just tends to throw people like way off. I don't know why. But you have to know how to calculate the area and the circumference. I'll probably do the diameter first. The area and the circumference of a circle, because that tends to be a bit of a problem. Now the circumference is the same thing as the perimeter. It's going to be the distance around a circle. I don't know why they decided to use a different name for it, but you have to know the relationship between those two as well. So the radius is going to be half of the diameter. So I feel like with circles, it's so much small stuff that you guys have to remember. I think that's why a lot of people tend to blank out, because with our other shapes, it's so black and white. It's length, it's width, it's side, it's height, it's base. It's not so much into it. But with circles, we're dealing with the diameter, we're dealing with the radius, you're dealing with circumference, you're dealing with area. And I think sometimes when you guys get so much information at one time, especially information that you have to memorize, it definitely becomes a really big issue in terms of retention. I think that people tend to get intimidated really, really, really quick, and that's the problem. What you thinking? Oh no, I still have to check you out though. Did you want one of those?
Both of those.
Yeah, both of these.
The small and the medium?
Mm-hmm.
Oh.
You have to
My baby thick.
So is it because it's getting more of the board and not my face?
Yeah.
Yeah, that's fine.
Oh.
It was like cutting your whole
Yeah, that's fine.
whole nose off.
Really?
Yeah, because I put the board up to you, like how you was to show the area and stuff. See, I could still get the board right here when the board that close to you.
And you can still
I
see
could
me?
still get the board and you.
You know what happened in one of my videos? I was talking and you couldn't see the bottom of the board. So that's why I've been pointing it down now, but you can see me in the board.
The
Oh,
whole
perfect.
Long.
those two.
Alrighty. You done bullied this lady into getting these mediums.
I'm gonna get
My
medium
baby.
and small.
My baby thick. So when she wanna be petite, she can be her petite. But when she wanna walk out all bodacious and thick and shit.
Oh. Are you guys doing a cash or card?
Card, please.
Okay.
Can you see the keys real quick?
My iPad is dead. 1 second, you guys. 1 second. So I have to. Thank you. Make sure you follow me on Instagram so you can send me your pictures.
You said every when?
Wednesday.
Wednesday.
Yep. Thank you guys for stopping by.
You have naked mannequins, so.
Yeah, I see. I'm gonna have to fix them. Alright, so back to our properties of circles again. The biggest thing that I think people tend to have a hard time with is definitely going to be the difference between our diameter and our radius. So the diameter is going to be a line that actually cuts our circle in half, and the radius is actually going to be half of that. So visually, I want you guys to be able to see what it looks like. So in the event that you get a word problem, you can draw it out, and based on whether they give you the radius or the diameter, you'll know exactly what it is. Thank you guys. What it is in reference to the circle. So again, the diameter is going to be the line that cuts our circle in half, and the radius is going to be half of the diameter. All right, so remember, so far we've been talking about perimeter, which is the distance around an object. So for circles, instead of saying the word perimeter, they're going to use the word circumference. So circumference has two different formulas. They have a formula specifically for the diameter if it's given, and they have a formula specifically for the radius if it's given. I always recommend personally that you choose one of the particular formulas to memorize, because there's no use in trying to memorize both based on what they give you, because if you understand the relationship between diameter and radius, it doesn't matter which equation you use, you'll know how to get to the answer. So if you're using the diameter, circumference is going to be pi times the diameter, and of course if you don't know, which most of you guys probably should know, pi is going to be 3.14. So if they give you the radius, circumference is going to be 2 times pi times the radius. All right, and then when we talk about the area of a circle is going to be pi times the radius squared. All right, and that's the thing that I tell people, is that if you get too comfortable like in doing your circumference and they give you the diameter, what if you have to find the circumference and the area and you don't understand the relationship between the radius and the diameter? That's what's going to kind of kill you. So make sure, again, I'm going to point out that you guys know the difference between the diameter and the radius and their relationship, and that the radius is going to be half of the diameter. All right. So again, circumference can have two different formulas. I recommend that you guys take one and utilize it, and don't try to utilize both unless you already have a good handle on it, then you're fine. So circumference can either be pi times the diameter, and pi is 3.14, or it could be 2 times pi times the radius, and the area is going to be pi r squared. So I'm going to give you guys some values, and we'll go through and we'll do an example just to make sure that you guys are grasping it content-wise. And of course, if you guys have any questions as I go, please feel free to drop a comment for me, and we will go from there. All right, so let's say, for example, we start out with a circle that has a diameter of 12 centimeters. So if I have a circle with a diameter of 12 centimeters, I know that the radius is half of the diameter. So anytime you cut something in half, you divide it by 2. So I know that half of 12 is going to be 6. So my radius would be 6 based on that. And these are the type of things that they want you guys to be able to know, is that if they give you the radius or the diameter, you're able to switch gears to decide what the value of the other one is going to be. So if we do circumference, we're going to say circumference is equal to pi times the diameter. So we know that pi is 3.14 and the diameter is 12. So we go ahead and grab our 4-function calculator, which you guys should be practicing with. We do 3.14 times 12, which is 37.68 centimeters. All right, if we do the area, and of course I'll show you guys this after I finish, which is pi r squared. If you guys notice, and as you'll see, anytime I'm doing a formula, I always write my formula out first, because that helps you guys to better retain. That's why some people, especially like math people, can memorize formulas so quickly, because we've written it so many times. Like I can only imagine in my lifetime how many times I've written this formula. Seriously. So you know that 3.14 is pi r squared. Radius is going to be 6 squared. So we know anytime we square a number, you're not doing a number times 2, which I'll show you guys when I do my walkthrough again. It's that number times itself. So 6 squared is the same thing as 6 times 6. So we're saying 3.14 times 36, which is what? 113.04 centimeters square. All right, so again, when we talk about circles are going to have a number of different properties, and I think that's the reason why it's so difficult for certain people, but you guys have to make sure you practice so that you're able to retain this particular information. So a circle is going to have a diameter, which is the line that cuts my circle in half. The radius is also going to be in relation to the diameter. It's going to be half of that. You guys have to understand the relationship, okay, that the radius is half of the diameter. All right, so instead of saying perimeter, the distance around, circles are going to use what's called circumference, which is the same thing, the distance around something. They give you two formulas. I always recommend that you guys utilize one so you're not teetering back and forth. So you can either do pi times the diameter, and pi is 3.14, or you can do 2 times pi times the radius. All right, so if I gave you guys an example and I said a circle has a diameter of 12, I know that the radius has to be 6 because it's half of 12. Anytime you take half of a number, you divide by 2. All right, so if we go ahead and plug it in, I said pi times the diameter. I did 3.14 times 12, and that gave me 37.68 centimeters because circumference is just like perimeter, so unit-wise, it stays the same. For area, we did pi r squared, so we know that pi is 3.14. Radius is 6 squared, and 6 squared is 6 times 6, not 6 times 2. So we do 3.14 times 36, and that gave us 113.04 centimeters squared, all right, because area is always squared. So I know from personal experience that people tend to have the hardest time with circles. So make sure you guys are giving yourself enough practice and reference to them so that when you get to your test, it's not a big thing. I know in terms of word problems, one of the most common things you guys will see in terms of circles is like something about pizza, because pizza is something that's super common in terms of circular shapes, like the bottom of a can or the bottle top. When you think of things like that, those may be real world situations that they put you in reference to the particular shapes. All right, and the very last shape that you guys need to know for the test is going to be a parallelogram. And you guys know the parallelograms have 4 sides, and it also has a base and a height, and you guys have to know this just in case they give you something in word problem form. So the perimeter of a parallelogram is going to be the sum of the sides. We just add everything together, and the area is going to be the base times the height. So again, being able to look at a shape and recognize what is definitely going to help you guys to be able to execute these problems efficiently. And of course, my drawing is a tad bit not perfect, but you guys get the idea. So with the parallelogram, it's going to have 4 sides. It's going to consist of a base and a height. The perimeter is going to be the sum of all my sides, which is going to be the distance around my shape. And the area is going to be the base times the height. So this is a general idea of what it looks like. I know it's not a perfect picture, so you guys can Google it so you guys know visually what a parallelogram looks like. The base is going to be the bottom. The height is always going to be determined by like a dotted line on the inside, which just helps you guys to be able to figure out the dimensions, all right? So if I filled in some values here, and I said my base was 10 inches and my height was 6 inches, we know that the perimeter, oh, never mind, the base is 10. I don't know, we'll do 8, 8, and 9. All right, so perimeter, we would do 8 plus 8 plus 9 plus 10, which would give us 35 inches, right? 8 and 8 is 16 plus 10, that's 26. Yep. And then the area is the base times the height, which is 10 times 6, which equals 60 inches squared. All right, so I added some values to our shape. And this is why it's really important for you guys to be able to know what the base of a shape is, because you see how we have all these other values. I don't want you guys not to understand that when we're doing our calculating our area, that the base is going to be the bottom. Okay. All right, so for our perimeter, we added up all the sides. So we did 10 plus 8 plus 8 plus 9, which gave us 35 inches. And then for our area, we did our base times our height, so 10 times 6, which gave us 60 inches squared. All right, and then this is going to cover a parallelogram. So what we're going to do now is going to go through a couple different practice problems, because that was just the properties of all the shapes that I know that you guys will see. Make sure that you guys memorize those formulas, flashcards if you have to. I always say the easiest way to memorize mathematical formulas is to write them every single time you do a problem, so that you can retain it, so that it becomes such a routine that it'll be really hard for you to be able to forget. So the first few practice problems we're going to do, we're just going to calculate the perimeter of given objects, and we're going to do this based on word problems. And then we're going to move into calculating the area, and then we're going to move into solving for the missing dimensions of figures. All right? And we'll go from there. All right, so first example, it says, Lisa is choosing new tiles for her kitchen floor. If the tiles measure 12 inches on each side, what is the total distance around each tile? So first things first, we're dealing with tiles, and it says the tiles measure 12 inches on each side. So if I know that normally tiles, we think of tiles, right? They normally have 4 sides, and we're just going off of normal assumptions, right? Because we're thinking of real world situations. And each side is 12 inches, I know that that's going to be the property of a square, because a square has equal sides. So for me, if I'm in my test and this is my problem, I'm going to draw it out, because visually I need to see what's going on. All right? I know this is a really ugly square, but just to give you guys the gist of it. So one more time, it says Lisa is choosing new tiles for her kitchen floor. If the tiles measure 12 inches on each side, what is the total distance around each tile? So I know, okay, I have 4 sides. Each side is 12 inches. When I think of the distance around, that's going to be my perimeter. And when I have a square, the perimeter, or any shape, honestly, I'm going to add up all my sides. So I'm going to do 12 plus 12 plus 12 plus 12. And that will give us our answer. So do you guys see how knowing the properties of a particular shape, as well as understanding context-wise what perimeter means, what area means, is what will help somebody to be able to solve this problem? Because sometimes people may not remember that a square has equal sides, you know, and not knowing that that's the particular shape. Or they may not remember that the distance around something is the same thing as a perimeter. So that's why it's interchangeable. You guys have to know. So if we do 12 plus 12 plus 12 plus 12, it's going to give us 48 inches. And that's it. So if we read our problem again, that's why I tell people word problems really aren't that bad if you master the content. You should be able to kind of really sail through it. So it says Lisa is choosing new tiles for her kitchen floor. If the tiles measure 12 inches on each side, what's the total distance around each tile? So first things first is you should have been able to recognize that if something is the same length on each side, that's a square. So that's my first trigger, right? So I draw my square and I do my 12 all around. The second trigger is they want to know what is the total distance around each tile. Another trigger, that's my perimeter, which means I just add them all together, and that's how we got 48 inches. All right. Let's go to our next question. It says the bottom of a cup has a radius of 2 inches. So before I even go any further, because I know that they're giving me the radius, I know automatically I'm dealing with a circle. Automatically, because that's the only shape, well, not the only shape, the only two-dimensional shape that is going to, sorry, my bad, that's going to give us the radius, right? So it says the bottom of a cup has a radius of 2, so I can already draw my circle. And I already know, boom, my radius is half my diameter, so that's going to be 2 inches. Because visually, I need to see what's going on. It says, what is the circumference of the cup's bottom? Boom. okay, I know circumference is going to be 2 times pi times the radius. So I'm just going to take the information that I have, I'm going to plug it in. We know pi is always a given. It's going to be 3.14, and that's something that you guys should definitely know. If you don't know it, you have to memorize it, because pi isn't even on a calculator. They're going to want you to approximate it, but normally they'll tell you they want you to approximate it, so you should be fine. So I'm going to do 2 times 3.14 times 2, which is going to give me what? 12.56 inches. All right, so we read the question again. It says the bottom of a cup has a radius of 2 inches. So because they gave us the radius giveaway, I automatically know I'm dealing with a circle. I know the radius is going to be half of the diameter, right? It says what is the circumference of the cup's bottom? So I know circumference is 2 times pi times the radius. So I do 2 times 3.14 times 2, which gave me 12.56 inches. Now, what if we had the same question and it says, what is the circumference of the cup's bottom in terms of pi? So anytime they ask you a question in reference to circles in terms of pi, what that means for you is that you're not going to actually insert the 3.14 in place of the pi. It's actually going to stand. So what do I mean when I say that? That means that if they asked us to answer this question in terms of pi, right? I know circumference is 2 pi r. Well, I know that I have 2 times pi, and I know the radius is 2. So we're going to do 2 times 2, which is 4 pi inches. So this is going to be the difference. So if they ask you something in terms of pi, that means that you have to stop in your tracks. So this is going to be something that you guys do have to know, okay? If they ask you for circumference or area and you do it full out, of course you're going to substitute in your 3.14. If they ask you for your answer in terms of pi, the pi sign will be in your final answer, okay? So you just combine all of our other elements. That's very important, and make sure that you guys are practicing problems that puts you in those situations, so that if you do get to it during your test, you'll know exactly how to execute it. All right, so do we have any questions, comments, or concerns before I move on to area? And again, we're just doing a couple practice problems. So of course, remember, they can put you guys in a variety of situations. It's so many different scenarios. In terms of calculating the geometric quantities, again, I just choose things that I feel like are the most common that you would see. But the book provides you with plenty of practice. I provided you guys with a host of different situations to make you think critically, so that when you get to your test, you're not in a situation to where you're like completely just thrown over. All right, so now we're going to segue into area. So our example 3 says, if a pizza has a radius of 10 inches, so I already know visually, let me draw my picture. I know the radius is going to be 10 inches. What is its area? All right, well, we know the area of a circle is going to be pi r squared. So look at our question one more time. It says, if a pizza has a radius of 10 inches, we know the radius is half the diameter. What is its area? So we know the area is pi r squared. Well, I know pi is 3.14, and our radius, of course, is 10. So we're going to do 3.14 times 10 squared. Well, we know that 10 squared is the same thing as 10 times 10, which is 100, which means that the answer is 314 inches squared. And because we're dealing with area, that's why that unit right there is squared, okay? Alrighty, so that was pretty straightforward. Now for the next question, I'm actually going to draw a diagram out for you guys, because you may be in situations where you get a diagram. And based on a diagram, you have to be able to decipher what information you need to pull out based on what they're asking you guys to do. And I know that this is one that tends to confuse people sometimes, because sometimes you have extra information. They want to know, do you have the ability to be able to sift through that information? Can you decipher the difference And if you guys have seen any geometry questions that you need help with, of course, feel free to drop them on the timeline so that I or someone else can chime in to be able to help you to get through some of your questions. Because again, the examples that I'm giving you, these are just the bones of the content, but you should be able to take what I'm giving you and apply it to questions that you get from anybody, from any book, from any private group. It should be it definitely should be something that translates across all topics. So this is our diagram. It says, based on this diagram, how many square feet does the living area cover? So first things first, living area is going to be this shape here. So that means everything else doesn't matter. That's the thing. People see this and see all these numbers. We have 1, 2, 3, 4, 5, 6 different values. That in itself is going to confuse people, but I know the question is telling me to specifically focus on this living area. So, and just looking at it, I know, well, this is a triangle. All right, the question also says, how many square feet does it cover? So that square feet thing is going to let me know my trigger is, that's area. Because area is always in square feet, because that's the space that it covers when we think about when you like go home, or when you're shopping for a house or an apartment and they tell you how many square feet it is, how much space it covers. All right, so I know that the area of a triangle is going to be base, which is the bottom, times the height, divided by 2. So as you guys can see, math-wise, it's not hard, but it's putting you guys in those situations to see if you understand that square feet is going to be area, and that based on this diagram where you're able to zoom in on a living area, understand that that is the same thing as a triangle. That's what they're looking for when you guys are taking this test, because arithmetic wise, it's not difficult at all. So I know my base is 10, my height is 15, so 10 times 15 is going to give me 150 feet square, or square feet. That's the same as that thing. All right, so I'll give you guys, I lied. Area is base times height divided by 2. What was I thinking? There we go. All right, so 10 times 15 divided by 2. 150 divided by 2, which is 75 feet square. All right, so one more time, the question says, based on the diagram, how many square feet does the living room cover? So when we think of the triggers that we're creating, first things first is I know that square feet means I have to find an area. And when I zoom in on the living room, I know that this is the shape of a triangle. So that's the formula that I'm going to use, which is base times height divided by 2. I know my base is the bottom, which is 10. My height is 15. So 10 times 15 is 150 divided by 2, which gave me 75 feet squared. All right, so with this particular topic, they could give you guys word problems. They could give you guys a diagram. They could just outright give you a shape and ask you different things about it. It's a variety of situations that they could ask you, that they could put you in. So you want to make sure that you're prepared for all of those. Whew, almost done, guys. All right, so our last part that we're going to focus on is going to be solving for missing dimensions in reference to geometric quantities. So sometimes instead of us having to calculate the area or the perimeter or the circumference, they may give us those things and then we're missing a dimension. So you could be in a situation to where they give you the area of a rectangle and they give you the length, and based on those things that they give you, you have to be able to calculate what the width is. And it's the same idea, it's the same formulas, but now you're kind of working backwards. Now we're kind of segueing into that solving equations thing, and that kind of helps you to peek into the idea, which of course is 2 clusters away. All right, so we look at our first example. It says the area of the basketball court at the local gymnasium is 1,200 square feet. If the length of the court is 40 feet, what is the width? So we know if we look at our properties of our shapes, the shape that's going to have a length and a width is going to be a rectangle. So let me go ahead and draw my diagram out, even though we know normally a basketball court is going to be in the shape of a rectangle anyway. All right, so let's fill out what we have. It says the area is 1,200 square feet, so I can go ahead and put that in the center, and it says the length of the court is going to be 40 feet. So we're trying to figure out what the width is. So the most important thing with these is making sure you identify the correct shape and apply the correct formula. So it says the area of a basketball court at the local gymnasium is 1,200 square feet. if the length of the court is 40 feet, what is the width? So I know if they give me length and width, automatically I know I'm dealing with a rectangle. So I drew my rectangle. They said the area was 1,200 square feet. I know that's the space that it covers entirely, so I put that in the center, and they gave us a length of 40 feet, so now we're missing the width. So I know in order to find the area of a rectangle, that's going to be my length times my width. So I'm going to write my formula out. And then now I'm going to fill in what I have. So instead of leaving the A for area, I'm going to put in my 1,200 feet, or 1,200. For my length, I'm going to put 40. And then my width, I don't know what it is, I'm going to put X. So now we have to solve. So I forgot 40 times what would give me 1,200. So of course, as you guys will see when I do get to equations, the object of equations is to undo everything that you see. So we're doing the opposite. We're basically trying to peel everything back so we can solve. So I know if I have multiplication on this side, this is 40 times X. If I want to solve for X, I'm going to do the opposite of that. And the opposite of multiplication, obviously, is division. So I'm going to divide out my 40 because I never want to touch my variable. I want to leave that there. So I'm going to divide both sides by 40. And these two are going to cancel out. And 1,200 divided by 40 should give us 30, right? Yeah. So 30 is equal to, oh, excuse me. All right, so again, that's going to be another sub-skill that you guys may need in terms of solving for missing dimensions. You're going to have to know how to solve equations. And of course, that's something that we're going to build on. So you guys should be fine and shouldn't stress about it. So one more time from the top, it says the area of the basketball court, I have to sneeze so bad. The area of the basketball court at the local gymnasium is 1,200 square feet. Whew. Bless me. If the length of the court is 40 feet, what is the width? So again, and I know I repeat myself 1,000 times, but I always want to make sure that everybody's understanding why we're doing certain things, understanding the process. How do we assess what the shape is? How do we assess what the formula is so that you guys aren't lost in the sauce? So it says if the length of the court is 40 feet, what is the width? So I know if they give me length and width, I know automatically I'm going to be dealing with a rectangle. So I draw it out. I know that they told me the area was 1,200 square feet. That's why it's in the center. The length was 40 feet, and we're looking for the width. So the area of a rectangle is length times width. So here, normally we're used to plugging in values on this side, length and width. That's why it's important to label things so you know where everything goes. So instead, the area went here for our A. We filled in the 40 for our length, and we were looking for the width, so we put an X there because we didn't know what it was. And anytime we're solving in any type of equation, we're going to undo, we're undoing, we're going backwards. What we see, so if I know originally it says 40 times X, I'm going to do the opposite of multiplication, which is division. Divide my 40 out on both sides, and we got X is equal to 30 feet. All right, we're down to the last one. Woohoo! Because I am exhausted and I need some food. I am starving. I am starving. All right, so example 6, last one. It says if the circumference, so before I even go any further, if they said the circumference of something, you automatically know I'm dealing with what type of shape. I'm dealing with the circle. So I'm going to go ahead and I'm going to draw my circle because I already know, I've already identified my shape. I've already got most of it done already. If the circumference of a tabletop is 75 inches, I'm going to fill that in. What is the diameter to the nearest tenth? So we're looking for the diameter. And then there's that sub-skill again of rounding. Because they want it to the nearest tenth, which means we're going to be dealing with a decimal. Well, first things first, I know that the circumference of a circle is going to be pi times the diameter, right? And then we, of course, know that pi is always going to be 3.14, and that's rounded. So what we're going to do is going to take what they gave us and we're going to fill it in. So instead of the C for circumference, we're going to put 75. Instead of pi, we're going to put 3.14, and we don't know the diameter, so we're just going to put X there. All right, so one more time from the top, it says, if the circumference of a tabletop is 75 inches, what is its diameter to the nearest tenth? Well, I know circumference already lets me know it's going to be circular. All right, so I put a 75 inches on the center to let me know that that was the area. I know that the area for the the formula for a circle, circle circumference is going to be pi times the diameter. We know that pi is 3.14, so we plug in the values that we have. So we're left with 75, which is our circumference, equals 3.14 times x. Again, because we're doing multiplication and we're solving, I want to undo that. So I want to do the opposite of that. So the opposite of multiplication is going to be division. So I'm going to divide both sides by 3.14 because we always want to isolate our variable. The idea is that we want to get this all by itself, so everything else has to move. So we're going to divide both sides by 3.14. And that is going to leave us with 23. Ooh, let me write up. That looks bad. 23.9. Ooh, that looks real bad. 23.9 inches is equal to x. Because if you guys did it in a calculator, you do 75 divided by 3.14. That's going to give us 23.88. I'll just write it out so you guys can see. It's going to give us 23.885. And of course, if we round it to the nearest tenth, that's the first number after the decimal. So we assess the value to the right of it because it's greater than 5. That means that the age is going to increase by 1. And then we'll go from there. All right, so one more time for the road before we get out of here. It says if the circumference of a tabletop is 75 inches, what is its diameter to the nearest tenth? Well, I know first and foremost, because I'm dealing with circumference, that's a circle. So I draw my figure out. I know circumference is going to be the distance around it, but I put it in the inside. I know we normally do an area, but I know it's going to be 75 inches. So from here, I know my formula is going to be, sorry guys. My circumference is going to be pi times the diameter, where pi is 3.14. So we plug in our values. Instead of c for circumference, we use 75. 3.14 instead of pi. We go ahead and we undo our math, and we end up with x is equal to 23.885, but the question specifically says to the nearest tenth, which is one number after the decimal place, so we round and we end up with 23.9 inches. So I am beat, because I feel like I've been up here forever talking about geometry. So all in all, when we talk about geometry, there are so many different situations that they could put you guys in terms of geometry. But for sure, you guys definitely know how to find the area. You need to know how to find the perimeter of different shapes, circumference, of course, in reference to circles. You guys also have to be able to calculate missing dimensions when we're dealing with particular, I just drew a blank, particular shapes, just like the examples that we just did. So you guys have to know the properties of squares, rectangles, circles, triangles, and parallelograms. You guys also have to know the difference between units when we talk about area and perimeter, and just remember that area in terms of units is always going to be squared, like inches squared or square inches or centimeters squared or square centimeters. You guys have to know all of these formulas because these are basic shapes they expect for you guys to be able to memorize. So my best advice is always to write the formulas as you're doing the questions so that you're able to better retain them. Anytime they give you guys a word problem and you don't have a visual in terms of geometry, always draw it out so that you can visually see what you guys are doing, so that you're least likely to make a mistake. If you guys have any questions in reference to geometry, please drop them in the comments, and I'll be sure to review it for you. The only other thing that I know that you guys possibly may see on your test that I did not go over today, which I'll do in a separate video because I do feel like it deserves its own video, is going to be the Pythagorean theorem, and that's when you're dealing with right triangles. Normally what they'll do is they'll give you a word problem that puts you in a scenario to where you have to use the Pythagorean theorem. And I know a lot of you guys are like, what is that? Well, it's not anything that's super big, but I will do a separate video dedicated to that because I know the video has already been long and cumbersome, and that can be a little confusing for people sometimes, and I don't want to kill your high right now, okay? So again, today we covered calculating geometric quantities, which is the end of our third cluster in the book. So again, if you are not familiar, Jesus, my words are everywhere. So sorry, really tired. If you are not familiar with the way that the book is structured, what I did was I broke the 15 topics down into 5 clusters, and I grouped the topics together based on similarity, based on your thought process, based on how they're solved, based on how you approach them, so that it's easier for you to be able to retain. So we just completed the last video for cluster 3, and cluster 3 included 4 different topics, which were explaining the relationship between 2 variables, evaluating the information in tables, charts, and graphs using statistics, interpreting relevant information from tables, charts, and graphs, and calculating geometric quantities. And the reason why I grouped all these particular topics together is because I felt like they all kind of deserve the same thought process in the manner in which you approach them, because a lot of these are going to include a lot of the word problems, a lot of our visuals. It has tons of visuals, graphs, and charts, and things that you have to look at, and you have to pull information from, explaining the relationship between 2 variables, more thinking about situational things. That's why I grouped all this in cluster 3, because this is the midpoint. Cluster 1 and cluster 2 were tons of computation. Cluster 1 was a lot of straightforward computation. Cluster 2 rolled you into that computation along with word problems. Cluster 3 kind of slowed you down and made you think a little bit more. So not as much arithmetic, not as much math, some math, but more thinking, understanding properties, and understanding different topics and how to look at a graph and how to read a graph. But again, still doing some of that math from the first 2 clusters. So next we have 2 more clusters left. Cluster 4 is going to be performing arithmetic operations with rational numbers. That's basically just knowing how to add, subtract, multiply, fractions, decimals, percents, all those good things. And then solving real world one or multi-step problems with rational numbers. That's just word problems with fractions, decimals, percents, and all those things. And of course, our last cluster is going to be our equations and inequalities and things of that nature. So following this video, I will do a video going over the questions for the diagnostic test that fall under cluster 4, which are going to be questions 17 through 24, and those will cover the questions that are in cluster 3. So of course, if you're having a really hard time organizing your studying, if you kind of don't know where to start, or if you're in a space and you feel like you're not going in the right direction, the book definitely is a good way to guide your path, because what it's going to do is it organizes the studying for you, and it helps you be able to continuously assess how well you retain information. So for example, if you were a person and you made the cluster 3 today, and you're like, oh, I feel good about it, but I kind of don't know where I am, what I did was I included a review for clusters 1 through 3. So all of those topics that I mentioned, from converting fractions, decimals, and percents, to estimation strategies, to our ratios and proportions and our percentages, all of those things, the clusters 1 through 3, there's a review which mimics a full-length practice test just for you, so you can assess how well you've retained information to this point. And that definitely is one of the biggest advantages to the book. I always wanted you to feel like you had a pulse as to where you are, instead of studying in the blind and waiting until you get to your test to see what you did and what you did not retain. Alright, so I know this video today was extra long. I'm gonna take a break, give me some snacks, and chill out for a little bit, and probably update inventory in the boutique while I wait for my phone to charge again. And I'll see you guys again for our questions from diagnostic tests. And then a little later, if I'm not too tired, we'll go ahead and we'll do another video. We'll run it back again with fractions for those of you who are still having a hard time. So thank you guys so much for participating. Thank you guys so much for joining the group, and make sure you guys are continuously spreading this great information and these great videos with other people. And yeah, that's pretty much it. So I'll see you guys a little later for my next video. And thank you guys so much for giving me your time. And I pray and I hope that everything that we talked about today helps you to study. And of course, remember, if there's anything that I missed, please feel free to let me know, and I'll make sure to go over it as well. Thank you.